another splendid moment discussing COLLATZ conjecture with you all. The COLLATZ conjecture is one of the most famous or well-known problems in mathematics. The conjecture asks whether repeating two simple arithmetic operations will eventually transform every positive integer into one. It concerns sequence of integers in which each term is obtained from the previous term. If the previous term is odd, the next term is 3 times the previous term plus 1. The conjecture is that this sequence always reach 1 no matter what positive integer is chosen to start the sequence. We have two key points here. If the term is odd, multiply it by 3 and add 1 to it. If the term is even, divide it by 2. So you will continue the process. You will find out that for every positive integer, the outcome is always 1. This is what is regarded as the COLLATZ conjecture, and there's a reward for anyone that can figure out the proof, which is 500 USD as promised. Now let's work it out with some numbers to have a clear understanding of the explanation. Since 5 is an odd number, what we have to do is to multiply it by 3. So we say 5 multiplied by 3 is 15, and when you add 1, you have 16. Now our next term here is 16. Since 16 is even, what we will do is to divide it by 2. So 16 divided by 2 is equals to 8. So our next term here is 8. Just ensure that you follow these two strictly. Now we have 8. 8 is also even, so when you divide this by 2, you have 4. And here our next term is 4. When you divide 4 also by 2, so 4 divided by 2 is also 2, and 2 divided by 2 is 1. So here we can see that our result is 1. Now let's try it out for 7 as well. For 7, since 7 is an odd number, what we have to do here also is to multiply it by 3. So 7 multiplied by 3 is 21, plus 1 we have 22. So 22 here. 22 is an even number divided by 2. 22 divided by 2 is 11. So we have 11. 11 is an odd number. So 11 times 3, 33 plus 1, we have 34. Now you divide it by 2. 34 divided by 2 is 17. And 17 is also an odd number. When you multiply it by 3 and you add 1, so we have 52. 52 here. So 52 is an even number. So you divide it by 2. And when you divide it by 2, you have 26. 26 here. 26 is also even. So you divide it by 2, you have 13. 13 is odd again. So you multiply it by 3 again. 13 times 3 plus 1. 13 times 3 is 39 plus 1. We have 40. Our next term here is 40. 40 is also even. So when you divide this by 2, you have 20. 20 is even again. When you divide this by 2, you have 10. 10 is even. When you divide this by 2, you will have 5. 5 is odd. You multiply it by 3. 5 times 3 is 15. Plus 1, we have 16. 16 as our term here. Now 16 is even. You divide it by 2. 16 divided by 2, we have 8. 8 divided by 2, 4. 4 divided by 2, 2. And 2 divided by 2, 1. Now I'm sure that what the conjecture demands is clear to everyone. The conjecture asks whether repeating two simple arithmetic operations, the first and the second. The conjecture asks whether repeating two simple arithmetic operations will eventually transform every positive integer into 1, as we've done so far. We have 4 more numbers as example. Now we want to try it with these numbers 9, 10, 12 and 21. We want to try out the conjecture with it. 9. Since 9 is odd, you multiply it by 3, that is 9 times 3 is 27. You add 1, that is 28. So we have 28. 28 is even. When you divide it by 2, you have 14. 14 is also even. When you divide it by 2, you have 7. 7 is odd. You multiply it by 3. 7 times 3, 21. Plus 1, we have 22. This is also even. When you divide it by 2, you have 11. 11 is odd. When you multiply it by 3, you have 33. Plus 1, we have 34. So when you divide this by 2, you have 17. When you multiply it by 3 and you add 1, we have 52. When you divide it by 2, you have 26. When you divide this also by 2, you have 13. This is even and this is odd. When you multiply it by 3 and you add 1, you have 40. When you divide this by 2 also, because it is even, you have 20. When you divide this by 2, you have 10. When you divide this by 2 also, you have 5. When you multiply this by 3, we have 15. You add 1, 16. So when you divide this by 2, you have 8. This is also divisible by 2. When you divide this by 2, you have 4, 2, 1. From 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. So you finally arrive at 1 here also. Another number. 10 is even. So you divide it by 2. We have 5. 5 is odd. You multiply it by 3. 15 plus 1. We have 16. 16 divided by 2. We have 8. 8 divided by 2. 4. 4 divided by 2. 2. 2 divided by 2. 1. So we arrive at 1 here also. Another number. Here we have 12. 12 is even, so we will divide it by 2. We have 6. 6 is also even. When you divide it by 2, you have 3. 3 is odd. Multiply it by 3. We have 3 times 3 is 9. 9 plus 1 is 10. 10 is even. So when you divide it by 2, you have 5. 5 is odd. 5 times 3, 15 plus 1, we have 16. 16 divided by 2, we have 8. 8 divided by 2, 4. 4 divided by 2, 2. 2 divided by 2, 1. The last random number here on my list is 21. Now 21 is odd. What we have to do is multiply it by 3 and add 1. So we have 64. 64 is even. You divide it by 2, you have 32. 32 is even. You divide it by 2, you have 16. 16 divided by 2, 8. 8 divided by 2, 4. 4 divided by 2, 2. 2 divided by 2 is 1. So our final result here is also 1. So this is the conjecture. The conjecture asks whether repeating two simple arithmetic operations will eventually transform every positive integer into 1. The simple operations are multiply by 3 and add 1, and the second is you divide it by 2. So those are the simple arithmetic operations, and there's a reward that awaits anyone who is able to figure out the proof, which is 500 USD as promised. So you can try out with bigger numbers, bigger numbers. Fortunately, you may be able to find out something important. So you can try out more and more with more numbers. Please subscribe, like and share. Thank you.